Yeah, we're coming into the sort of afternoon session now, our sort of third key topic of the day. We've looked at building safety, we've looked at sustainability, and the third topic we've chose for today's conference is artificial intelligence. I gave Karen a little bit of an introduction at the start of the day, but just please welcome to the stage Karen Burns, Chief Exec and Co-founder at Fyma. Karen.
Thank you. Hi, everybody. So like mentioned, my name is Karen. I'm the CEO and co-founder of Fyma. We are a business that works with computer vision and mostly with commercial real estate developers. We work here in the UK, but also across the pond in Canada and in the US. I started my career in the IT sector in British Telecom in Edinburgh in 2005 in Telephony House in Gorgie, if anybody knows that. So it's been quite a while since I started. And I've worked extensively with cybersecurity, AI, technology adoption, etc. In the Nordics, namely in Estonia and Finland, but also here in the UK and in the Middle East as well. I'm currently a member of the Tech and Innovation Board at the Urban Land Institute. So we're looking at how to adopt not just AI, but technology in general in the built environment. And previously, I've also led a cybersecurity and tech group as part of Estonia's Defense Industry Association. So I've got some defense and cyber background as well. Now, before I start with any of my slides, I've got a couple of questions. How many of you use an AI tool in your work every day that you need to be using? Brilliant. Lots of people. And how many have played around with ChatGPT just in your free time? Brilliant, and Copilot probably as well. Awesome. How many of our companies are actively promoting adoption of AI tech? I don't know if you have maybe a corporate license to ChatGPT or Copilot, etc. Okay, so a bit less than the first and second question, but probably an area that will be growing. So today I will talk about what is AI, a little bit about deep learning, computer vision, its history, and then applications and potential applications in the built environment as a whole and in the different kind of areas of built environment. First of all, artificial intelligence is a field, superset, if you will, that tries to either be equal to a human in what it's able to do or be better than a human in what it's able to do. So if you put it in an equation, AI is greater or equal to human in its capabilities. That's how we could basically really, really easily explain AI. And that encompasses everything from movement and the area of robotics, vision, so computer vision, text-to-speech interpretation, and so forth. So everything a human could do that a computer is trying to emulate will be AI. A subset of that, and very closely underneath AI, is machine learning. Now, machine learning is not the same as AI, and sometimes I hear in panels that people say AI is machine learning. It's not. If you're doing machine learning, you are doing AI, but not all of it. So in the field, we used to say a few years ago that AI is more of a science fiction term, that we still talk very specifically about either deep learning applications or machine learning applications, so they're not the same. Machine learning sits underneath AI. And then you have traditional algorithms and deep learning. So deep learning is something that your LLMs will be powered by, really, really, really vast networks, computational networks, basically, crunching lots of data. So when we talk about deep learning and machine learning, we have supervised learning. We also have unsupervised learning, and then we have the neural network. So that's the three types of machine learning that mostly is discussed. And neural networks are what are most popular and kind of used in most of the applications that we use, probably in our daily work as well. There are really simple ones, maybe 3 or 4 layers. So a really simple algorithm in machine learning could be, if you want to figure out the price of a product, your 3 inputs could be price of commodity, price of distribution, price of labor, computing that, and then spitting out an end result. And then you don't program that, you just change the inputs to get a different outcome. When we talk about deep learning, those neural networks get hundreds and hundreds of layers deep. And when we talk about generative AI, which ChatGPT, large language models are all about, then they get even deeper. So they essentially learn on petabytes of data, just vast, vast data sets. And then once you have a first iteration of an LLM out, you work with tuning it. So tweaking the inputs to be able to get a better, more accurate output, essentially. So when we talk about ChatGPT-4, that will be the most latest tuned LLM that we'll be working with, which has been tuned to be more accurate and more better. So essentially, that's some of the concepts that I wanted to cover when we talk about AI and generative AI. Now, if we put all of this into an embedded timeline, you can see that AI has been around in some form or another for nearly 70 years. So machine learning emerged in the 80s. Then we get into deep learning in 2010s. And then very, very recently, are we only in the generative AI kind of field. And it feels like this is really boosted AI into the kind of common domain. So when previously AI, even 5 years ago, we did lots of R&D projects around AI applications. Now it's become a lot more urgent because there are very practical applications for us as just individuals when we use AI. So I was just sharing earlier how ChatGPT helped me do all of my UK customs documents in about a minute. So I'd prepared to sit down for 2 hours with all of my stuff that I needed to ship. In June, I shipped 3 tons of my personal effects back into the UK. And the customs documentations, just off the back of some of my unstructured notes, took only about 2 minutes to be completely structured into a table, numerized, and summarized as well. So this has really helped, I think, properly adopt AI on a larger scale. A little bit about generative AI. So it's learning on vast data sets, yes. Actually, generative AI has been around for quite some time in statistics already. It's only recently that it's been able to move beyond just simple maths into visual. So that's your Dolly, your Midjourney, and also into text generation as well. So that's Copilot, ChatGPT, et cetera. But as a concept, generative AI is not 2 or 3 years old. It's a lot older, and it's been used in statistics for a while. Similarly, like computer vision technology has been around also for quite some time already. Then generative AI is still a very simplified output of the data it's been trained on. It just doesn't copy what was put in, so it iterates what it was trained on. And that's why you're able to get, give me a Van Gogh-style image of the Construction Leaders Summit auditorium, for example. So it will know what's within the data set, spit out something that's within the vein of that, but not a direct copy. If you would be able to see a neural network, it looks like a human brain, and inside of it are what we call weights. So those weights determine in which way the outcome of that computation will kind of go. So if you input specific data into it, you could basically, let's say, hack it for the outcome to be a little bit different, because you change the weights within that neural network. And that's how we also tune a neural network. So for example, when we work with computer vision and I want to teach an AI to recognize what an e-scooter looks like, if I feed it too many images of I don't know, a monobike or a bicycle, it will start confusing objects. The input has to change for the output to be more accurate. Barriers to adoption. So AI is something that, like I mentioned, it looks like there's finally momentum building because of all of this hype and discussion and ChatGPT, et cetera. We work with commercial real estate developers a lot. And the main barrier is just people, resistant to change within their organizations. So unless the leadership has really fully committed to embracing the technology, it's very unlikely it will happen. So there are often pockets within the business that are either called digital buildings, or they're called innovation, or they're called even data teams who work with AI. Unless they have proper decision-making authority and budget, it's very unlikely that AI will be adopted beyond just some proof of concept projects that really don't make it anywhere beyond the newsletter. So the biggest barrier to adoption that we're seeing across the various industries that could adopt AI is human behavior. The next one is cost. So in order, like I mentioned, for AI training to even be able to take place, you need vast amounts of data. And often we find out that the data either does not exist, or if it does exist, it's really poor quality, patchy, and the outcomes in that case will not help the business. It could be the other way around. So cost of adoption, especially for small and medium enterprises, is really big. The third one is trust into innovation. So a lot of the innovation is obviously coming out of the startup sector, out of the US, which is a lot faster to innovate because of a lesser regulatory barrier. And the cycle for a building is so long that a lot of those businesses may not be around once you actually put something live. So in the tech sector, we're seeing that the adoption and kind of perhaps even boldness to work with those type of innovative companies is perhaps a bit lacking. But that's something we'll discuss at the panel later as well, and looking forward to some of your questions. I thought everybody loves a cat picture, especially on an afternoon after lunch. And the story of computer vision actually starts with cats in 1959 already. So that's the year when some neurophysiologists were testing with cats to see how their brain reacts to specific images. And they figured out that the immediate response is to harder edges and lines before it moves on to softer ones. So there's a hierarchy in how we recognize an object that we're looking at. So that's the very kind of beginning of how to teach computers to start to see, essentially. So it does start with cats. Nowadays, obviously, computers can see all sorts of stuff in real time, compute that data across millions of miles in near real time, classify objects, etc. That's a cargo bike here. We can look at heat mapping, how objects move, what kind of trajectories they create, and so forth. However, when we look at the kind of timeline of computer vision as such, so yes, 1959, we had the cats and the neurophysiologists working with them. In 1974, so 50 years ago, optical character recognition technology was put live. And also around 60s, computer scanning technology also became available. So if you think that OCR has been around for about 50 years, one of my friends runs a business out of France, which is trying to help customers make sense of their vast amounts of lease contracts. And the clients very often say, yeah, everything's digitized. We put everything online, we have PDFs, etc. But what often happens is that there's a photo of a lease contract without the content actually having been digital. So although the tech to understand what's written in a contract has been around for quite a long time already, what now some of these AI businesses are finding is that even that technology was poorly adopted, which means that the data sets weren't collected to then be able to now work with that data. 1982, so just a bit before I was born, the first computer vision kind of algorithms popped up that were able to understand hard edges and lines in an image. So what those cats were seeing in 59, in 1982, a computer vision algorithm was basically a neural network was able to detect. And then real-time face detection. This has been around for over 20 years. So 2001 is when real-time face recognition algorithms were already basically available. And now they're really entering into the mainstream. As a business, we've been asked to do things like heritage detection, age, gender, all sorts of things. Completely legal in the UK and also in the EU, but technically absolutely possible. And data sets have been around for that for quite some time. There we go. If you like cat pictures, you also like dog pictures. So just 24 months ago, it was very difficult, not just for a human, but also for a computer to try and understand whether it's a muffin or a chihuahua, right? I told ChatGPT, well, I gave it the task of figuring this out, right? So let's see, and I wanted it in a nice table, etc. And it does a really, really, really good job out of it. So you can see that, right? And it doesn't just tell you whether it's a chihuahua or a muffin. It tells you whether it's a puppy chihuahua and which way it's looking as well. So the sophistication at which we've arrived in just such a short amount of time in detecting the detail in these images is pretty amazing. Now, AI within the built environment. So the value chain that I use is from an organization called Minna Learn. So if any of you want to just do a really quick course about AI in construction, the built environment, it's a Finnish government kind of funded AI course, free of charge for the public use. The real aim is to showcase Finnish companies, but if you overlook that, it's actually a very good quality course to have a look at in terms of, okay, I just want to do a quick dip my toes into this. And it's divided into 5 areas that we're looking at. So urban planning, real estate development and planning, construction, property management, and demolition and recycling. And AI can obviously be used and is used, and its use is increasing across this entire value chain. Planning and development, so everything from smart cities, traffic development around this, predictive analytics projects, environmental monitoring, transportation networks, all sorts of simulations, etc. AI can come into our aid to help us model all sorts of movement patterns and behaviors here. There are lots of companies doing any part of these components. Some have recently popped up, some have been around for longer. Mobility planning is probably one of the more kind of mature ones that's been around for a long time, because the innovation into that's been driven by telcos. Some of the other fields here have been just kind of emerging, and specifically around public engagement, decision-making, sentiment analysis. These are more marketing, kind of short-term projects in our experience. Property management is also something where AI is, like, we can see that the use is increasing. Everything from energy maintenance, efficiency, predictive maintenance as well. Predictive maintenance is also now moving from office buildings into residential. So there's a pretty interesting company in the US, for example, called Dwell Well. And for private tenants, what they offer is a sensor that goes into your house, multiple locations in your house, and it basically, what they claim is that just by the way the toilet flushes, they can tell you when it's going to break. And there's, I don't know if I want a company overhearing all of our activities in the bathroom. However, their claim is that just by analyzing the voice, they're able to do predictive maintenance in your house, whether that's related to your plumbing, your heating systems, etc. So there's pretty cool companies popping up trying to do that. Indoor air quality has been around for quite some time. I think it kind of surged with COVID, and then now that we're in offices less and less, it's kind of waned in its importance. And then some of the smart contracts I already mentioned. There's a big French company working with contracts and leasing and so forth. Building security, access control, etc. A lot of this stuff has been around for quite a bit of time. Adoption However, so despite the tech being available, adoption's been more difficult. Again, this is very often driven because of budgets being controlled either by a single building manager, in which case, if you have a portfolio of 600 buildings, it's really difficult to sell that into everything. The building owner usually decides whether they're going to put anything in or not. The property management businesses that do all of this sort of procurement centrally are usually in a much better position to adopt not just 1 or 9 or 7 from this list, but all of them. A brilliant company that does this really well is Quadrille in Canada. So they're one of the larger developers, asset management companies in Canada. So they have built a proper in-house data analytics and AI team. So they've really invested into actually hiring these people into the business and empowering them to procure all sorts of AI tech property management solutions for their entire portfolio, not just into building by building. Urban planning and AI. So this is a really emotional topic usually. So yes, there's lots of movement data. Dependency on data quality is vast. But then again, telcos know absolutely everything about where we are, where we go, how fast our phone is moving. So are we in a car, or are we walking? And all of that data can be crunched into analytics around how we should do our urban planning. Data also often comes from Wi-Fi sensors. Some IoT sensors. There's more sensors for car traffic than there are for pedestrians. So again, when we think about the inputs into a neural network, if that data is biased, the output will also be biased. I was involved in a project with a Nordic capital where they had used microwave sensors to understand basically car traffic per lane, and the sensor would tell them whether a vehicle is long or short. So they were only really able to distinguish between a bus, a truck, and a normal passenger vehicle. Each sensor was only able to cover 1 lane of traffic. So if you think about a really large junction, that required a lot of sensors. And they weren't measuring anything around pedestrians, cyclists, none of the micro-mobility stuff that you should also be taking into account when you work with urban planning. The other issue they had was that the company they procured them from installed them incorrectly. So they installed those sensors in front of a traffic light. So if you imagine a car going under a traffic light, or in front of a traffic light, often it would count a single vehicle up to 4 times. So there was all this phantom traffic that wasn't ever really happening, and they were building road network for traffic that wasn't really there. So, and nobody checked, because you have election cycles, politicians come in, and nobody really went in and checked whether that sensor technology is properly accurate or not. That's probably a really poor change management and an implementation program, but it's not an outlier in terms of how it's trying to collect data from an urban environment and then utilizing that data in a really poor way. The large picture that is also now emerging is, yes, gig economy is growing. Post-COVID, we are in the offices a lot less. So how should our urban environment respond to that? I think earlier it was mentioned also about how places make us sick. People really do want to be closer to where they live and work and play and buy their goods. I mean, Jan Gehl, in the 70s already said that the best urban mix is 50% necessary and 50% optional activities. So when we plan our urban environments, that's something that should be taken into account. And AI, again, can come and help us in terms of the inputs into those models to aid human beings in the planning work. Demolition and recycling is one of these areas where it's very heavily regulated. And it could be used again, and it is used in all of these various fields, but adoption has been slow into this particular field. Some of these waste sorting plants are using computer vision, for example, to understand what type of material they're looking at. About 5 years ago, I was involved in a project where we had to map trash on roadsides. Just understand basically what would be the most optimal way in cleaning that up and coming up with a cleaning kind of pattern. And it's really difficult to teach AI. It's gotten a lot better, but 5 years ago, to teach AI what is trash, because, for example, this bottle right now is not trash because it's on a table, and then if I throw it on the floor and it's on the roadside, it becomes trash. So you need to teach AI a lot about the context in which it sees a specific object. And in the very beginning, it was classifying all the road markings as trash and the humans as trash, so you had to train all of that stuff out. But in the end, the algorithm that we came up with was pretty accurate. And it's obviously evolved since then. But again, the investment into the tech needs to happen before these sorts of applications can be used. For example, when we look at recycling plants and so forth. Construction, health and safety is one of the really big drivers in using computer vision and AI. So things like helmet detection, safety gear detection, areas in a building site where people are allowed to go to, where they're not allowed to go to, et cetera. Supporting project management on a construction site. In our experience, we've seen that construction companies, even within a single company and between the sites that they have live, the data quantity and quality can be really vast in terms of what they're able to collect from a single site. So unifying that sort of work would be brilliant to be able to then go and adopt AI. Because, between all of these stages in the value chain, the data usage is either really poor or non-existent. So the potential is there, it's vast, but data is often not there. So if the data is not there or the data is poor, the maxim that we use is rubbish in, rubbish out. So AI won't work unless you train it with really good quality data. So what about the future? Some trends and kind of movement that we're seeing. Yes, adoption is slow, but it is growing in terms of its interest. So when you look at construction companies using AI, just 4 years ago, 12% were using AI. It's set to double by the end of next year, but it's still only a quarter of businesses that could be using and adopting the AI. Predictive analytics, safety monitoring, progress tracking. Yes, next 5 years we'll see a pretty big increase in those particular fields. The fastest growth is being seen in AI-powered drones. So this is, like I mentioned, site monitoring, progress tracking, et cetera. And I mean, if you look at the number, it's really big. When I was working in the Middle East a few years ago, you couldn't even fly a drone in Abu Dhabi, for example. It was completely illegal. So regulation has changed somewhat to enable that. Regionally, it's very, very different, depending on which continent and which country we're in. And AI adoption has been very, very fast in safety and compliance. Again, where shoe squeezes the tightest, that's where AI adoption will be the fastest, purely because of compliance and the fines and so forth, as we know, are really quite steep. When we look at regional differences, the US is absolutely the world leader in adopting AI in construction. However, these are all the big high-profile companies, Turner Construction, Bechtel, Skanska has been adopting AI in really well. There's lots of fantastic case studies that I recommend that you can just find online. The small to medium-sized construction companies still remain quite far behind. Again, the cost of kind of starting all of this stuff up is just too high for them. Also, the investment in terms of venture capital and also just capital into AI businesses in general is much bigger in the US. So all sorts of construction tech companies in the US are much better financed than they would be in Europe. And that's really crucial because building cycles are so long that when you're building technology for them, you have to have enough runway to be able to be around until a specific building goes live and to be able to support a client throughout an entire life cycle of a building. Europe, sustainability here is bigger because of the Green Deal in Europe. So the pressure in terms of regulation has been more on the ESG sustainability side, and AI is a great helper in that. But construction's kind of more fragmented and cautious because, again, regulation is more of a worry and a burden here. Even when we talk about computer vision, the way GDPR has been adopted in every single European country is completely different. And then there is no one certifying body. So when we go and say we are GDPR compliant, I have to kind of prove and reprove that in every single European country because of really heavy regulation and justifiably very heavy fines as well. Yeah, in terms of the US, so we see that, and I think this is the case in everything. US builds tech, regulation follows. Europe does it the other way around, which is why adoption here has been lagging. And the rest of the world, China is a big global leader thanks to the state-backed mega projects. So there's a lot less bureaucracy to get through because the state is so strongly pushing all of this stuff to be live. Middle East, I'm sure we all know about NEOM and the line, which is probably now more of a millimeter, but I was in Riyadh about a year ago on one of the really large PIF fund tech conferences, and there's a lot of PR, obviously, around adoption of AI in that particular region. Whether that is actually properly going to happen, I think we'll see, but the talk is definitely there. Some investments absolutely there as well. But they are really hungry for AI tech to be an enabler for smart city projects. And Latin America is very much a laggard. So traditional construction methods, slow adoption of technology, and so forth. So right now is one of those moments where upskilling workforce to be ready to use AI is pretty crucial. So again, looking at some of the customers that we've worked with over the past few years, there are companies that are so far ahead, and those where I'm being said, yeah, AI is maybe like a bit of a crypto thing, it'll go away. And it's unbelievable that somebody would say that if they want to really get their company to be successful and profitable in the next, not just 5, but 10 and 20 years. So how many construction companies do you think consider themselves to be on the cutting edge of AI adoption? It's a pretty small number. It's just 5%. So the future of construction is just not about building structures, but also building smarter and safer and more sustainable environments. And I strongly believe that AI is the key to unlock that future. And with that, I thank you, and we'll go to the panel.